So what are you here for?
Lately, I've been having trouble seeing past 25 centimeters. Everything just seems so blurry past that. What about you?
Really? I have the exact opposite problem. I can only see things past 25 centimeters.
Well, let's hope this optometrist knows what she's doing.
Caroline, are you here? Hi, Caroline. I see that you've been having trouble seeing past 25 centimeters.
Yeah, I've been having this problem for quite a while now.
You shouldn't have waited so long to see me. Let's go give you an eye exam.
Okay.
Is this any clearer?
Yes.
How about this? Is this any clearer?
No.
How about now?
No.
Last one.
Yes.
So I'll have you wait outside in the waiting room while I figure out your prescription.
Okay.
The nearsighted patient has a far point located only 225 centimeters from her eyes. I need to determine the focal length of glasses that will enable this patient to see distant objects clearly. I also want to figure out the power of the lenses for her glasses that I should prescribe to her. We will start by using the thin lens equation. F equals focal length, S equals distance from lens to object, and S prime equals distance from lens to image. The thin lens equation is 1 over F equals 1 over S plus 1 over S prime. We want the patient's far point to be infinity, so S is equal to infinity. The patient's far point is 225 centimeters, but we must convert this to meters, so 2.25 meters, S prime. S prime is negative because the lens will create a virtual image. Using the information I got from the patient's eye exam, the thin lens equation should be 1 over F equals 1 over infinity plus 1 over negative 2.25. So 1 over F equals 0 minus 0.44. That means F equals negative 2.25 meters. Since the focal length is negative, the lens must be concave or diverging. The power of the lens is P equals 1 over F. So you would use P equals 1 over negative 2.25 meters, and so the power would be negative 0.44 diopters. So from what it seems like, it looks like you have myopia.
Is that bad?
No! Here's your prescription. I even included the calculations I did to find them in case you were curious.
Thank you.
Hello, Emmeline, are you here? Hi, Emmeline. This is your first visit with me, right?
Yeah. I've just been having trouble reading anything closer than 25 centimeters. It's pretty frustrating. And from time to time I have headaches and eye strain.
Okay. I can see why you may be frustrated. I think I have an idea of what may be going on. But let's give you an eye exam first. Here's the first one. Is this clear?
Not really.
Okay, let's try another one. How about this? Is this clear?
Oh yeah, that's better.
Cool. I got something to work with. I'll have you wait out in the waiting room while I figure out your prescription. Next is on to my hyperopic patient. The far-sighted patient, after a thorough eye exam, I determined that she could not clearly see objects that are closer to her eye than 72 centimeters. That means I need to determine the focal length of her glasses that will allow this patient to read a book at a distance of 25 centimeters, as well as the power of the lenses I should prescribe her. We are given that the near point distance for this eye is 72 centimeters, which means that the eye alone can focus an object that is 72 centimeters away to produce an image on the retina. So if the image produced by the lens at this distance or greater, the eye can produce a final image at the retina. The image distance, or S prime, equals negative 72 centimeters. It is negative because the lens will create a virtual image. Therefore, to find the focal length, I must use the thin lens equation. In this case, I'll plug in the numbers, and the thin lens equation will be 1 over F equals 1 over 0.25 plus 1 over negative 0.72. Therefore, 1 over F equals 2.88, and F equals 0.347 meters, or 34.7 centimeters. Therefore, the focal length is positive, so the lens must be converging. The power of my patient's lenses can be found using the power equation. In this case, P equals 1 over 0.347 meters, and the power therefore equals positive 2.88 diopters. It seems to me like you have hyperopia.
Is that bad?
Not really. Here's your prescription. I even included the calculations I did to find them, and just in case you were curious.
Oh, cool. Thanks.
Of course.
Hey, looking good.
Hey, God for physics and the study of refraction, right?
I know.